Chapter 26, Alcohols. Alcohols are an important class of organic compounds, and as we just saw, we can easily form alcohols when we hydrate the alkenes at specific conditions. Now, when we refer to commonly the term alcohol, just one member of this very large family comes in front of us, and that is ethanol, which is C2H5OH. And that's because this is the only drinkable alcohol in the entire homologous series. This is the only drinkable one. That's why this word is so familiar for us for this at all, and some are even extremely poisonous or toxic. Let's start with the very basic of alcohols. The first four on the list, methanol, ethanol, propanol, and butanol, have the similar set of formulae. You would notice that their formulae go in the same technique. We sometimes write it like this, CnH2n plus 2O, or we may write it like this, CnH2n plus 1 OH. Whether you write it like this or this, it means the same thing. Okay, because this one applies to this one and this one applies to this one. I hope that makes sense. However, the displayed formula remains the same for all 1-ols. Remember, if it's a 2-ol, of course, the displayed formula is going to change, and it's the isomer. You were asking something?
Yeah, isn't it 2n plus 2, not 2n plus 1?
Sorry, I didn't get it.
Why does it say CnH 2n plus 1 under the next to ethanol?
Now, this one and this one means the same thing. This yields the molecular formula, for example.
Yeah, again.
All right.
Yeah.
And this yields the structural formula. Why do we yield the structural formula like this? There is a specific reason behind this one, in order to tell you the functional group, because this does not differentiate the functional group. This is just the molecular formula, but this specifically differentiates the functional group, which is OH in this case. And when OH is attached to an organic molecule, that specific organic molecule turns into an alcohol, hence the name functional group. And that's why we have this line. So this formula gives us the molecular formula, and this specific general formula gives us the structural formula. I hope it makes much more sense now, right?
Yeah.
Okay, so moving on. When drawing the displayed formula for alcohols, you must show the bond between OH like this. This is a very important hint. Okay. Also, propanol and butanol are acceptable to use in exams. Unless they talk about isomers, you are supposed to differentiate them as propan 1-ol or propan 2-ol. But if they're not talking about isomers, your answers may contain the word propanol, and it would still be considered as correct. When I use the term propanol, and the formula is like this, C3H7OH, or the structure is something like this, CH3, CH2, CH2OH. The word prop means the 3 carbon atoms. The word N means that they are singly bonded. And the word O means that there is a functional group of alcohol present. So again, every part of the name would make its own sense, would play its own part. So I hope you understand how to convert the name into structure or structure back into name. Right?
Yeah.
Okay. This completes the naming part as well. Now let's talk about the reactions. Oxidation of alcohol. We're going to begin with this one. This is much like combustion. Ethanol burns in air. We call it a biofuel, a fuel that is made from biological sources such as sugarcane or corn. Mixtures of petrol and ethanol are increasingly used in countries such as Brazil, which have little or no oil industry to produce their own petrol. On the other hand, we often have a climate which is good for growing sugarcane. Other countries are also introducing biofuels, such as ethanol, to reduce dependence on fossil fuels, which are finite and actually non-renewable resources. Because at one point, the humans will consume all the petrol on the planet. What then? So we need to come up with some renewable resources. That's why we're digging so much into wind energy and solar energy, maybe other forms of energies as well. So this is supposed to give you the same set of products. However, their balancing is a little tricky. Let me define why. Now, you would notice that oxygen over here is a part of carbon dioxide as well as a part of water. But don't forget this single oxygen atom
Your
over
voice
here.
is lagging.
Okay, I am trying to tell you the tip to balance this equation. What I was saying is that this oxygen
Your
is
voice is
divided.
lagging.
Okay, can you hear me now? Am I audible? Okay, good.
Yeah.
So I was saying that oxygen is converted into carbon dioxide and water upon reaction. But when you're balancing this, don't forget this single oxygen atom over here. So now you would notice that 2 into 2 are 4 and 3, 7, but 3 into 2 are 6. That's because there is another atom present over here. So try balancing this equation from me. Go ahead.
Okay.
Don't forget, there are hydrogen atoms and oxygen atoms in the structure of alcohol which are not written in the same place. I mean, not as a whole.
Yeah.
Yeah, that's what I was talking about. You are forgetting that this oxygen is also
yeah.
present. Now you get the point. Good, good. One thing that you can do while you're balancing this equation, as soon as you're done with carbon dioxide and water, now 3 2s are 6 plus 4 is equal to 10. Subtract 1 out of it so that you can take this oxygen out. You're left with 9 divided by 2 and write the number over here. There you go. You can easily balance the equation.
Yeah.
You can do it quickly and correctly. So let's move on. Ethanol is oxidized by air in presence of microbes or microorganisms. If a bottle of wine is left open to the air, it turns sour. The French for sour wine is vinegar, which is distorted into this name that we currently use. Actually, ethanol is converted into ethanoic acid by microorganisms such as bacteria or yeast. So you would notice that in this structure, we have 2 less hydrogen atoms and 1 extra oxygen atom. The old name for ethanoic acid was acetic acid, and this was the common method to convert alcohol into vinegar. Leave it open for some time, it would turn sour, and the alcohol would convert into vinegar. However, we now do it by using chemicals. We can oxidize ethanol by using potassium dichromate 6 in dilute sulfuric acid. Now, the usual way of oxidizing alcohols in the lab is using an oxidizing agent, potassium dichromate 6 in dilute sulfuric acid. Potassium dichromate 6 is a very strong oxidizing agent. The formula is K2Cr2O7. Dilute sulfuric acid is important for it to act as an oxidizing agent. Without the H positive ions, no reaction will occur, redox reaction in specific. Now, a few drops of ethanol are added to a solution containing the orange mixture of potassium dichromate. It's its natural color, and as soon as it goes with its oxidizing reaction, it is turned into green. So what do? You take this tube, you put it into a hot water bath, and as soon as you heat it a little, the reaction proceeds, and the orange mixture of potassium dichromate 6 works its way towards a green color, which means the reaction has proceeded and the alcohol has been converted into its counterpart of carboxylic acid. Or in simple ways, ethanol has been converted into ethanoic acid. All right. Now, there are a couple of things that we need to note. In the name potassium dichromate 6, di tells you the word that there are 2 chromium atoms. And then the Roman numeral 6 tells you that they have an oxidation state of 6 plus 6. Remember, we have seen these symbols before in chapter 7. Cu2 means that Cu has a plus 2 charge, or Fe3 means Fe has a plus 3 charge. Dichromate ion is Cr2O7, which has a charge of -2, but chromium in specific actually has a charge of 6 plus. That's why we write dichromate 6 in words. This is important to understand. One more thing, wear eye protection and add the reactants very slowly because that reaction can be violent. Do not point the mouth of test tubes towards you or any of your friends because the contents may spit out. Okay. The solution turns green and now contains a very dilute solution of ethanoic acid together with other products. The green color indicates the presence of chromate 3 ions, which have been converted from chromate 6 into chromate 3 as reduction. So the oxidizing agent reduced itself and oxidized the alcohol into carboxylic acid. We frequently show this reaction with using a simple O in brackets, a single O. Hence, if we move on to the next page, you'd see the reaction. So alcohol plus 2 oxygen atoms give you the acid and water. So as soon as you add 2 oxygen atoms, one of the oxygen atom is added to the structure. It takes 2 hydrogen atoms out, and the other oxygen atoms reacts with them to form water. So the starting material is ethanol with potassium dichromate 6. We also need dilute sulfuric acid. Conditions, we need to heat under reflux in order for this reaction to happen. This is a flux condenser. Water goes in from one side, water goes out from the other. Actually, this arrowhead was supposed to be in this direction. This is a mistake by the book, so make sure you correct it. Water in goes towards in, not towards out. All right?
Yeah.
So this reflux condenser makes sure that the organic product does not evaporate out of the system and gets back into the system by condensing it down so that it drips back into the system. That's why reflux condensers are used. You can use this reaction to make a sample of ethanoic acid by heating ethanol with excess of oxidizing agent in the flask with the condenser placed vertically at top. This is noted as heating under reflux. Condenses any vapor so that they run back into the flask and don't escape, as I just said. When the reaction is complete, the condenser is rearranged for a simple distillation. Ethanoic acid and water are both distilled out, and a solution of ethanoic acid is collected. So I think it's pretty simple. As soon as we are done with this reaction, we perform a simple distillation. I hope you understand that, right?
Yeah.
Okay. Up next, the topic doesn't finish. Production of ethanol is a very important thing in this course. And what we do in this course is that we look at two different processes side by side with their advantages and disadvantages. So have we studied the processes? Yes. In order to produce ethanol, the first process that we studied back was hydration of alkene. And the second process was just fermentation. Let's study the second process first, then we're going to compare both. First, we're going to start with fermentation. Yeast, which is actually a fungus, a specific type of microorganism, is added to sugar or starch solution and left in warm about 30 degrees centigrade for several days in the absence of air, anaerobic conditions, so that the yeast or the enzyme can convert the sugar into ethanol and carbon dioxide. This process is known as fermentation. Fermentation is a pretty old process. It predates back to Egyptians and Babylonians. Even they knew how to convert the fruit juice into alcohol. The absence of air, the temperature are both important. The presence of the air would turn the conditions aerobic, and instead of ethanol and carbon dioxide and water will be produced. So anaerobic conditions are maintained in order to produce ethanol. Enzymes in the yeast produce carbon dioxide and water instead of ethanol in aerobic conditions. However, in anaerobic conditions, ethanol and carbon dioxide are produced. The enzymes are protein catalysts. They don't work if the temperature is increased above 40 degrees centigrade. They lose their structure, don't work any longer. We use the term denatured for those proteins. At a lower temperature, the reaction is too slow to complete. So anywhere between 30 and 40 degrees centigrade is actually the optimum temperature for the reaction to work. So we need an optimum temperature, and we need yeast, and we need anaerobic condition for the fruit juice to be converted into alcohol. Moving on, I actually was just clearing it up. Okay, so moving on, let's study this reaction in detail. The biochemistry is very complicated, so we don't discuss biochemistry over here. What we discuss is that we can simply convert the glucose into ethanol and carbon dioxide. However, they have discussed that the sucrose can be converted into glucose and fructose.
Hello?
Sucrose is
Your
the
voice
common
was
sugar. Okay, let me repeat. Can you hear me now? Okay, can you hear me now?
Yeah.
Even the best of internet in Pakistan go in and out like this. Unfortunately, I'm unable to do anything about it. No matter how high you pay, they always drop like this. All right, getting back to it. So I was talking about the extension work. Sucrose.
Your voice is lagging again.
All right. Can you give me a minute? And I can just go and check the router and I'll be back here. All right. Give me a minute and I'll be back. Okay.
Your voice is lagging again.
Can you give me a minute and hold on? Okay, so I was saying that the fruit juice or sucrose, which is the most common sugar that we eat every day, even the white refined sugar is sucrose in formula, is converted into glucose and fructose upon the action of water. Now, the glucose, however, is something that enzymes are interested in. They convert glucose into ethanol and carbon dioxide. So this is the reaction that you need to memorize. Not this one. This one hasn't been a part of past paper or exams. Remember, the starting materials was glucose from sugarcane. It may even be fruit juice. All right, because that also contains glucose. The starting temperature can be anywhere from 30 to 40 degrees centigrade. Optimum is better. It means it should stay in this range, neither below this range nor above this range. The enzymes in yeast should be there, and the conditions should be anaerobic. Now, I think everything is understandable on the list except the last one. Means the starting material comes from a fruit or sugar cane. The temperature has to be kept the same. The catalyst is that you're going to use yeast. Yeast comes in powder form. You're simply supposed to put that powder into the juice. However, this anaerobic conditions is something that is not clear yet. Let's see if we have clearance of it on the next page. No, we don't. That's easy. Edexcel keeps it easy. So you just need to remember the anaerobic conditions. You're not going to allow oxygen in the system, right? How do we do that? It's not discussed by this Edexcel system, so let's keep it easy, right? Now, as soon as we proceed with this reaction, there is a big problem. Yeast is killed by about 15% of alcohol in the mixture. So it's impossible to proceed with further reaction and produce pure alcohol. So what we do, as soon as 15% of the reaction is complete, we stop the reaction. The reaction actually stops itself. So the alcohol is purified by fractional distillation. This takes advantage of the difference in boiling points of ethanol and water. Water boils at 100, ethanol boils at 78. So we can easily distill ethanol out of the system first, right?
Yeah.
Okay. Now, we already have gone through the system, this one, where ethene was hydrated by using steam and was converted into ethanol at 300 degrees centigrade temperature, 60 to 70 atmospheric pressure, and in the presence of phosphoric acid, which acts as a catalyst. Now remember, for this specific reaction, we use the term that it yields high purity ethanol, right? And for the system above, we have already discussed that this produces a little amount of ethanol and we fractionally distill it out of the system. So let's compare both the systems. As soon as we are going to compare both the systems, what I'm going to do is that I'm going to use some symbols. If I use A in a cell, that means advantage of that system. If I use D in a cell, that means disadvantage of that system. So you can exactly talk about advantages and disadvantages of the exact systems. Now, when we talk about uses of resources, fermentation actually uses a renewable resource. Sugar beet, cane sugar, corn, starchy materials, they can be renewed every year with a new crop. So that's actually an advantage. However, hydration of ethene is a finite, comes from non-renewable resources. Once the oil of the wood has been consumed, there won't be any more ethene. So this comes as a disadvantage for this reaction. Type of process. It's actually a batch process. Everything is mixed together in a reaction vessel, left for several days, batch and then removed. A new reaction is set up. This is inefficient, so of course, a disadvantage. However, hydration is a continuous flow process. A stream of reactants are constantly passed over the catalyst. This is much more efficient, and the process goes on 24/7, which means it is actually an advantage. So we can safely say fermentation is a slow process for every batch. Disadvantage. Continuous flow process is a very quick process, hence advantage. Fermentation produces very impure ethanol, which needs further processing. Of course, fractional distillation is what we are talking about, so that's a disadvantage. This produces very pure ethanol, so that's an advantage. Fermentation uses gentle temperatures, atmospheric pressures, which makes the process simple, so that's an advantage. However, hydration of ethene uses high temperatures, high pressures, requiring a high input of energy, which puts it onto a disadvantage. So you would see that both the processes have their own advantages and disadvantages, right?
Yeah.
Good. Have you noted them down?
Yeah, I've taken a screenshot of them.
Okay. When you're done, let me know. I can erase it and move forward. Okay.
Yeah,
I've
I'm
taken.
done.
Okay. So at the moment, many countries have easy access to crude oil. They can produce ethanol from ethene, but one day there won't be any oil, so this reaction will not be an option on the face of the planet, which actually ends this chapter.